Hey guys, so welcome to the rates of reaction revision video. What I'm going to do is I'm going to very quickly go through all the knowledge that you need to know for this topic. There's a couple of bits of information not on these slides that I will tell you about, and that's how to measure rate reaction. But let's go through it. So you know that in order to follow the progress of chemical reactions, changes in mass, volume, and other quantities can be measured. Essentially, what that means is in order to tell how fast or slow a reaction is, you can see the change in mass as chemicals get used up and gas is released. Volume of gas is an incredibly common one, and other quantities, sometimes pH maybe, and that's a really rare one, but I have seen a couple of past paper questions based on it. You know that for mass loss, you use the electronic balance you can see in the slide. For gas loss, you can use a gas syringe or the displacement of water method, which is where you've got a delivery tube that goes down and up into a upside down measuring cylinder full of water. Gas bubbles up, pushes the water down. You can measure the volume of gas throughout the reaction. This can then be used to draw a graph, and this graph can use to define the endpoint, the quantity of product, and the effect of changing reaction conditions. Remember that the steepness of the curve, the steeper the curve is, the faster the reaction. Remember that the amount of gas that's given off is dependent on the amount of chemicals that you use to begin with. So if you've got half the amount of gas given out, you can assume that one of the chemicals you used half the amount of. Okay. Rates of reaction can be increased by increasing temperature, increasing concentration, increasing surface area, decreasing particle size, or using a catalyst. Okay. Remember that all of these have the purpose of increasing the number of collisions. Okay. Increasing temperature makes them move faster, so they collide faster. Increasing the concentration means there's more particles, they're going to collide faster. Increasing surface area, there's more surface area, so the more collisions can happen. And using a catalyst, it's complicated. You'll learn more about it in higher, but essentially it holds chemicals in place so that they're not all whizzing past each other. It holds one chemical and the other one can bump into it much easier. Okay. Remember that catalysts are substances that speed up chemical reactions but can be recovered at the end of the reaction unchanged. The last thing that you need to know is this is the calculation for rates of reaction. Okay, rate equals delta Q over delta T. Remember, delta means change in, so change in quantity over change in time. And the units depend in the quantity and time. So if you are measuring the gas given out, that's going to go first on your units. And if the time is in minutes or seconds, that's going to be the second part of the units with a -1. Okay. The rate of reaction decreases over time during the course of the reaction. Essentially, what that means is the chemicals get used up. Once they get used up, then it's going to slow down. There's going to be a less concentration, so which means slows down the reaction. Okay, so that's essentially rates of reaction. It's not a big topic. I know it's sometimes one that people struggle with. So feel free to go ahead and go do the mind map and then the past paper questions. Okay, thank you guys.